Hey everyone, I'm Anish and welcome back to PrepFusion. So this is the lecture 8 of root locus diagram. So this is the last lecture of root locus where we'll solve few questions of whatever concepts we learned in the previous lectures, and we'll try to summarize everything, right? Summarize our learnings, what we learned, and we'll try to apply it here. But before starting, I want to mention one thing, that if nothing is mentioned, right? If nothing is mentioned, then always assume as normal root locus. So I will write a key point over here. If nothing is mentioned, then solve using normal root locus method. So you can solve using like this. So yeah, this is what I wanted to mention. Now let's start with the lecture. So let's start with the first question. So what is the first question telling us? So first question has a unity feedback system. Like a unity feedback system has a transfer function like this. The transfer function has been given. This is not the OLTF. Okay, or like this is confusing. Now unity has transfer function like this. The value of b for which all the roots of the closed loop characteristic equation meet at the single point. Now it is asking us to find the value of b in all the three roots of the closed loop characteristic equation meet at the single point. So this has told here transfer function, but here it is telling us to find the value of b. Okay, and also from here, if this was the transfer function, right, of the whole system, then obviously we don't have plot the root locus, and obviously it has told like all the three roots lie at the same point, and here we can directly observe these are not lying at the same point. So obviously they should have mentioned it more clearly that this was the open loop transfer function, but they haven't. But what can we do? But from this statement below here, we can understand that this is a open loop transfer function. That is point number one. So from the below system statement, OLTF is given. This is the point number one, and we have to find b. Now this is not a root locus problem per se, because simply what you have to do, we have to equate something. So what is the characteristic equation? The characteristic equation is 1 plus g of h of s, right? So 1 plus g of h of s, so this is 1 plus k into s plus b divided by s square into s plus 20, which is equals to 0 itself. So what does it become? It becomes s cube plus 20 s square plus ks plus kb equals to 0. So this is what this becomes. Now what the question has told us? The question has told that, wait a second, that all the three roots of the root loci lie on the same point, meet at the single point. So what can we convert this equation to? If all of the three roots lie on the same root loci, what does it mean? It means this one forms a cubic equation. Only then three roots will lie on the same point, and three roots are there, obviously they will be real or whatever they can be. But we can write, we don't know the location of the roots, but what we know is as all the roots lie on a single point, then this equation 1 equation 1 can be written as this s plus, let me write with a different color, equals to 0. Now I will just rewrite this equation. This one will become s cube plus 3 s square into s plus a plus 3s into s plus a whole square plus a cube. Now this one becomes s cube plus, okay, this one also changes. Wait, am I doing something wrong? Oh, sorry. I was doing something wrong. Really sorry. Like I was in some of them. This will be simple A, right? This will be simple A. I was in some different band itself. Simple A, and this is A. And yeah, so this one we can compare, right? This one we can compare here. So s cube has this coefficient 1, that is fine, but this has coefficient 20, s square has coefficient 20, and this has coefficient at 3a. So 3a, so this is 2 equating coefficients of 1 equals to 2. Then what information do we get? We get that 3a should be equals to 20. 3a should be equals to 20. This is the first information. So a, what will be a equals to? A will be equals to 20 by 3. So value of a we got. Now let's go to the second coefficient, this one. So this is 3a square. This will be equals to my k times s. So here we will get the value of k. We will not get the value of b directly. So this is not a question of root locus per se, because simple cubic equation you have to solve. So not a question of root locus, but still. So k is 3a square. That is fine. Now I will put the value of k here. So kb equals to a cube. So next page. Kb equals to a cube. What is k? K equals to 3a square. Into b equals to a cube. So b equals to a by 3. Now what is a? A is 20 by 3. So b will be equals to 20 by 9. This is how you solve this question. You don't replace the a value here, then you get the value k in absolute terms, then you again replace the value of k here, then you again replace the value of a here with 20 by 9. Don't do that. Do simplification. Put the values at the end when you are almost at the end result, when you are almost getting the end result. So very important how you solve the question also. Just not the concept, but how to solve each question in the examination itself. So this one was very simple, pretty simple question, right? Just had a bit of confusion regarding this. The unity feedback system has a transfer function. So this is not the closed loop transfer function. This is the open loop transfer function. And here, as they have mentioned that the roots lie in the three same points, obviously we know how to equate those two. So yeah, this was it for this question. So what is this next question telling us? Next question is telling that the root locus diagram of a closed loop system is shown below. We have to find the range of k for which the system will be overdamped. We have to find the range of k for which the system will be overdamped. Now, what do we mean by overdamped? First of all, where does damping, like, where have we studied the concept of damping? Damping is studied in the second order system. So this should be a second order system. Is this a second order system? So let's clarify that. So here, right, they have given like two colors. So these colors represent the branches. You will understand. So here they are showing that there are two k values and like two roots. They are starting from here and they are ending to here, vertical zeros. So fine. This has two branches. Hence, the how many closed loop poles we will get? We will get two closed loop poles. Hence, this is a second order system. Hence, this will have the concept of damping present, obviously. Now what type of damping, that we'll understand. So here number of branches. So how many number of branches we have? We have two number of branches, hence closed loop poles, two closed loop poles. So we have two closed loop poles, hence this is a second order system. Concept of damping present. There will be some damping will be present. Concept of damping is valid. So now let's understand in what areas we have, like what do you mean by damping. So damping are of mainly four types: critical damping, over damping, under damping, and undamped. So four damping types are there in first second order system. Now each of them has few characteristics with it. The closed loop roots lie in some pattern for each of this damping. Can you recall that? So for critical damp, what does the roots lie? Roots lie on the real axis and they are repeated. They are repeated itself. So from here, can you identify which locations will be for what values of k I will get critical damp. So here, if you see for 2 and 5, k equals 2 and 5, I will get critical damp. Why? The roots are repeated roots on the negative real axis. So here, like at this point, the two branches are breaking in together. So here I have two roots, and hence I will get critical damping at this k equals to 5 value. Here also I will get critical damping at k equals to 2 value, as two branches are breaking out from here. So this is a break out point and this is a break in point. So yeah, breakout means breakaway point. This is a breakaway point and this is a break in point. So very important to understand. So this is a breakaway point and this is a break in point. So here at these 2 points I will get my critical damp system. Now can you tell me, will I get undamped system? Can I get undamped system? No, because this is never crossing the imaginary axis. So obviously I won't have a natural frequency. That's why I won't get a undamped system. Can I get an underdamped system? Yes. What are the characteristics of the roots for the underdamped system? It was my roots should be complex conjugate of each other. So here this is like lying totally in the complex plane. Here I have complex roots, so obviously between this k to 2 to k to 5 I will have complex conjugate roots, so hence I will get underdamped system. Now for overdamped system, what was the where the location of the roots? The location of the roots were negative unequal real roots. So there were negative unequal real roots. Here I can see that as they are breaking in, here they are not equal. Here at this point they became equal, and after that they break away and they become what? They become complex. But here they are negative and real and unequal. So between k equals to 0 to 2, I see I have negative real unequal roots. So k I have negative unequal real roots. So here I can say that my system will be overdamped. Now is this the only range of k? Is this the only range of k? Can you identify another range of k? So there is obviously another range of k. What is the other range? Other range is this one, right? So after the break in again, after they come together again they separate obviously. So here we have negative roots and they are also unequal here. So here also we get overdamped system. So for this is just simple question, right? This you can solve in 30 seconds, even like less than that. But I have to explain it to you. That's why this, right? This can come as MSQ here. This can come as MSQ here. Now, one more thing we have to note that, okay, just wait. This is, yeah, k less than, yeah, this is fine. This is fine. So yeah. Also for k equals to 0 also this is valid, right? This k equals to 0 also this is valid. So this k equals to 0 it does include, like, be mindful of that. So here MSQ may come or some other form of questions may come, right? I just wanted to explain you this, that's why. So this is it for this question. Pretty simple, nothing like spectacular. So now let's go to the next question. Next, what is the next question? Next question is, for the following OLTF, what will be the real parts of my complex closed loop pole as k tends to infinity? Now it is asking about the real parts of my complex closed loop poles as they tend to infinity. Now can you answer that? Can you answer that? So whenever k tends to infinity, what things should come to your mind? Virtual zeros, asymptotes, all those things should come to your mind. So they are telling us about k tends to infinity. So first we'll think about the asymptotes. Where does my asymptote lie? Where does my centroid lie? All those things as k tends to infinity. So first let me draw the pole zero diagram, and from there you'll get a brief idea. This is sigma, this is j omega. Now I have two poles at the origin. So two poles are at the origin, and I have one 0 on the left hand side and one pole also. 1 0 at minus 1 by 3. So 1 0 I have minus 1 by 3 and one pole at minus 1. One pole at minus 1. Okay, these are the things. So can we just directly draw the like the root locus from here? We can, I think we can. Like this is simple. So obviously this, on the right hand side I have odd number of poles plus 0. So this is lying in the root locus, and this is a nothing is mentioned. Nothing is mentioned, so we will assume normal root locus. So first point is nothing is mentioned. Normal root locus. Okay, so we'll assume normal root locus. Now we got this point. So obviously this on the right hand side I have odd number of poles zeros, so this will lie on the root locus. So it will start here and terminate here. Okay, k equals to 0 and k equals to infinity. That is good, that is fine. But what about the other two roots? So whenever I told you, right, whenever I have repeated roots, what will happen? I will have what? Break away point. I will have break away point. So obviously they will break away like this, like complex poles. But how will they break away? Will they break away like this, or will they break away like this, or how? So how will you understand that? So maybe we can't understand like how will they break away without knowing the angle of arrival and angle of departure like that. So we're not interested in that, calculating that right now, because we just have to find as k tends to infinity, as k tends to infinity. So k tends to infinity is talking about the asymptote, so we are not interested in how they are ending, where how they are starting. We're interested in how they are ending. Okay, but for your information it will be something like this. Okay, if we want to calculate the angle of asymptotes, angle of asymptotes. So angle of asymptotes, what are they? So here simple, use that formula. So what was the formula, if you remember, if you haven't forgotten? So angle of theta asymptote. minus 180 2k plus 1 pole minus z k equals to 0 1 p minus z minus 1. Simple formula. So here I have 3 poles and 1 0. So I have 3 poles and 1 0. 3 minus 1. So this will be minus 90 and 3 minus 1 2 minus 1 up until this will it will go. So 0 k equals 0 and k equals to 1. So k equals to 1 if you put here, if you put k equals to 1 here, what do you get? 3 by 2, so minus 270, minus 270, or you can put simple plus 1, it also it doesn't matter. So here what we can observe is, let me copy this. So this are obviously my angle of asymptote. One is minus 90 from the real axis, one is minus 270 from the real axis. So these are my asymptotes, right? So obviously k equals to infinity, k equals to infinity. This is k equals to 0. I just check, wait a second, everything is recording or not. Let me check. Everything is fine, dandy. Yes, everything is good. So I have to check in between sometimes. So everything is recording. Now this is k equals to 0. And what else we have to notice? We have to notice, like, what is the question asked us? The question has asked us that where will what will be the real parts of my complex closed loop poles as k tends to infinity. So what are my complex closed loop poles? This is like a real pole. This is like a real pole. So this will the question is not talking about this one. The question is talking about these two. So these two are my complex conjugate poles, and it is asking us to find the real parts. Now this is the definition, right? When, like, what is the definition of a centroid? The definition of centroid is where the two asymptotes meet at the real axis. So basically it is the same thing. So we have to find the real part of the complex conjugate poles, or here as my asymptotes are at minus 90 degree and minus 270 degrees. So what is happening? The real parts will be tending here, right? The real parts will be here because the distance is constant. This distance is constant with respect to j omega axis, but obviously the imaginary part is increasing. Imaginary part is keeping on increasing, but the real part is constant. So like homework you can do, you can make the real part constant and you can find the imaginary parts, and like, or you can, what you can do, you can make k tends to infinity in 1 plus g of h of s, 1 plus g of h of equation, and you will see that my real parts are constant but my imaginary parts are changing. Like we will use this concept in the polar plot, and from there you will understand. Okay, don't worry if you don't understand. Here we will use this concept in polar part multiple times. When my real part will be constant and my imaginary part is going to infinity. So here the definition of centroid is still the same, because only my angle is minus 90 and minus 270. Only then, else I wouldn't have been able to tell this. As my angle is minus 90 and minus 270 degrees, then only I am able to do this. Because minus 90 means what? What does minus 90 represent? Minus 90 represents j omega axis, and minus 270 represent minus j omega axis. That's why what I can observe is it is going in this direction, in the minus j omega axis and in the minus j omega axis. Hence these two, the imaginary parts are increasing but the real parts are constant, because the distance from the j omega axis is constant. Got it? And that distance is, we can find out by centroid itself. So only then we can use this centroid as the answer of this question, else we couldn't have done that. So just be careful about that. So centroid will give of complex conjugate poles as what, as my angle of asymptote theta asymptote is minus 90 and 270. So this is the case. So what is my centroid? Simple formula. Sigma c is summation of poles. Yeah, summation of the poles, real parts of like anyway summation of poles itself, and summation of my zeros minus number of poles minus number of zeros. So like what is the summation of poles? So here we have like open loop poles, I mean like two poles are 0, so 0 plus 0 0, and here I have one pole at minus 1, so it becomes minus 1 here, minus 1 minus summation of zeros, so I have 1 0 here at minus 1 by 3, only 1 0, so minus 1 by 3, and what is this becoming? P minus this, so it is 3 minus 1, 3 minus 1, 3 minus 1. So it is 1 2 by 3. So 1, okay, so 1 minus, no, so 2 minus 2 by 3 divided by 2, so it is minus 1 by 3 itself, minus 1 by 3 itself. So this is the answer. This is the answer of the question. So this is the answer of this question, minus 1 by 3. So obviously the the real part are lying on the 0 itself, 0 itself. Okay, this is just a coincidence, nothing to be serious about. So the minus 1 by 3 will be answer. Now let's go to the next question. So next question is telling us we have to find the angle of asymptotes for the below system. So angle of asymptotes we have to find, very simple, right? So basically we know, like let's just find the OLTF itself, or OLTF we don't even have to find, we just have to find how many number of poles and zeros we have. So here what is my OLTF? OLTF is very simple, right? OLTF is this times this. Now OLTF is s plus 3 s plus 1 s plus 2. So this is my OLTF. Now if this is my OLTF, obviously how many number of poles I have? Number of poles I have is 3 and number of zeros I have is 1. The same thing. So they have just told us to find the angle of asymptote. So theta asymptote, very simple, right? This question I took just for one reason. You will understand. If you have understand, then do tell me in the comments if you have understand that. Yes, I have understood. So theta asymptote will be minus 180 or plus 180, whatever you choose, doesn't matter. Minus 180 into 2k plus 1 divided by p minus z. So basically it's 2, and it will go on till 0 1, k equals 0 comma 1. K equals 0 comma 1. So this is what like my theta asymptote is. So my theta asymptote is this. Obviously it will be minus 90 and minus 270, just like the previous case. But only here, like the previous case, it won't be like the previous case, that this will be wrong. Why this will be wrong? Because if you are in such a hurry that you are missing the type of feedback. Okay, don't be such a the purpose of taking this question was only one thing, that don't be in a hurry. And while solving easy questions also. Just check if everything is given or not. Sometimes yes, it happens that sometimes a very easy question, laddu question comes, but sometimes they give you a bit of trick questions. They give you the easy question, but with some one minute changes. So here minute change was positive feedback. So don't skip that. So in the question also they may mention that k is varying from minus infinity to 0. K is not varying from 0 to infinity. So that may also happen. So just be careful about that. Just be careful about that. So if k is varying like this, that like it is a positive feedback. K is varying like this. K is varying like this. Okay. One thing I messed up is I should have written here k also. That is my mistake. Okay. Just I wanted to take this question. Just wanted to trick you guys, but I myself got tricked. So k will be obviously present, obviously, and I will say that k will obviously vary. K will obviously vary like this, 0 and infinity. So this is important. So k will obviously be vary like this. Now let's solve the question actually. So what was the formula for? So here system is in positive feedback. So if my system is positive feedback, so theta asymptote formula will obviously change. It will be 360 into 2k plus 1 divided by 2 into what? K equals to 0 comma 2. So sorry, not 2, k equals to 1. Like, or we can do like this. So 2 k into k, it was into k, so it was 0 degrees and 180 degrees. So this is also what we can do. So yeah, if we put k equals to 1, yeah, 3 by 2, 0 degree and 1 degree. So this is the answer, not that one. Just be careful about that, right? So yeah, this is it for this question. Let's go to the next question. I'm thinking about something. 2k plus 1, if it is 2k, k equals to 1, and k equals to 1, 2, 3, 8, 20, 2, 3. Yes, yeah, that's fine. 180, 180. Sorry, like the previously what I wrote, right? That formula was wrong. Obviously, it is 360 times k divided by 2, or like any multiple of, like it was odd multiple of 180 degrees, and here it was, sorry, it was even multiple of 180 degrees here, and it was odd multiple of 180 degrees here. So yeah, that is the thing. Sorry if I move out for the mic. What I was speaking was, it was odd multiple of 180 degrees here. If you recall it correctly, it was odd multiple of 180 degrees here in the normal root locus, and in the complementary root locus it was even multiple of 180 degrees. So this was the formula for even multiple of 180 degrees when I have complementary root locus. So yeah, don't be in a rush. Solve it slowly. Sometimes like we also make mistake. So now we have to find the intersection of asymptotes on the real axis for the following OLTF. We have to find the intersection of asymptotes on the real axis for the following OLTF. So this is again simple only. Just I wanted to show you one concept, and then obviously we'll wrap up. This is very simple concept. So to find the intersection of asymptote on the real axis. So how to find the intersection of asymptote? Basically, centroid give us the intersection of asymptote on the real axis. So centroid will give us that. So what is my sigma c? So for that we have to find the location of poles and zeros. So where are my location of poles? So here we have only poles. This one and this one, both of them we don't know. So we have to solve this too. So how to solve this too? How to solve this one? So this is s square plus s plus 1 equals to 0. Equals 0. So obviously simple Sridharacharya formula, -1 plus minus b square minus 4ac, b square minus 4ac, which is 1 minus 4 divided by 2, and this is s square plus 2s, what was this, 2s plus 2 equals to 0. This is minus 2 plus minus b square minus 4ac minus 4, like 4 times 2 is b square, which is 4, minus 4 times 2 is 8, so minus 2 by 2. So these are complex conjugate. So what we have to do is simply add these two up, right? So these two are plus minus, so if we add these two, if I we have two roots here, and if you add those two roots here, but this will get cancelled out, this will get cancelled out, only we will be remained with this. So we are only remained with minus b upon a. So I've already told this in the previous videos also. So only minus b upon a, like the formula, that formula, right? If I have a quadratic equation like this, that let's say I have a quadratic equation like this, a square plus bs plus c. This is like bachpan ka thing. So if I have a quadratic equation like this, no need to further find the roots for sigma c. No need to for sigma c. This is very important. What you will do instead, what formula we know, that minus b upon a, what is it? This is sum of roots. Sum of roots. How is this the case? So you can see from the formula itself, this is plus minus. If you add these two roots, these are my two roots. If you add these two, obviously this part is getting cancelled. And what is this? This is minus b. And what is this? This is 2a. But this is minus b upon a itself. So because what is happening? Minus b is getting added twice. So minus 2b by 2a. So it becomes minus b upon a. Do you understand that? So my sum of roots becomes minus b upon a, as the imaginary part gets cancelled, or the real part also gets cancelled, because they're simple conjugate. Okay, not complex conjugate, but a simple conjugate. So yeah, that is the case. So you don't even have to solve. You don't even have to solve. So directly you can write from the from the equation itself, that sigma c will be sum of the poles minus sum of the zeros. Now what are the sum of the poles here? Sum of poles is minus b upon a. So this is minus 2 upon 1 minus 2. This is minus 1 upon 1 minus 1. So minus 1 and minus 2. Minus the zeros divided by p minus l. Number of poles, how many I have? 4, right? 4. So 4 minus 0. So this becomes minus 3 upon 4 minus 0.75. So this is my answer. Very simple, very simple. So yeah, this is the main reason for taking this question. Just to tell you one shortcut, we don't even have to calculate all this. We can directly calculate from here. So yeah. So this is very important. Now let's go to the next question. So next question is also very simple only. So what is the next question telling us? We have to for the following characteristic equation, find the okay, something has happened. Okay, yeah. For the following characteristic equation, find the value of x if my characteristic equation is this. We have to find the value of x. X is where? X is the centroid. This is the k. Let me write this properly. This is the k. And x is here. So basically we have to find the location of centroid. So obviously centroid will lie on the real axis itself. So we just have to find the centroid. But for finding the centroid, this is sum of the roots minus sum of the sum of the poles minus sum of the zeros by number of poles minus number of zeros. But here what do we have? Like this is not a standard equation. So like if this type of question comes, so I have taken the last session like this, so whatever different unique questions came in root locus, right, you will be able to solve. So if this type of equation is given, so what you have to do, you have to convert it standard root locus format. So first is convert in standard root locus format. We have to convert in standard root locus format. So if we convert in standard root locus format, how to convert it? Basically, your k, you have to take common k. Like I will show you. Single term. Let me use the color. With k. So what you have to do is you have to take the k terms together, or I can say so if you want to how to take the k terms together, so here what we will do is we'll separate out the other terms. S cube I have separately 11s square, and this is plus plus 45s, and k terms I will take together. So this one will become k, I will take common as I was mentioning previously, and this one will become s plus 1, s plus 1, which is equals to 0 itself. So this one becomes 1 plus k. Now I can convert this into standard format. S cube, s I can take common here, s square plus 11s plus 45 equals to 0. Now this is simple only. I will use the previous method that I used in the previous question. Sigma c will be summation of poles minus summation of zeros, and what is the summation of poles? Minus b upon a minus 11 upon 1. So this is minus 11 upon 1 minus the zeros. So where is my 0 line? It is lying on the minus 1. So if this type of question come up, they won't tell you how, like, you convert it to simple format. So as k is varying, so you have to convert it by yourself. Nothing will be said in the question. This is minus 1 and divided by p minus z. Number of poles is 3 here, and number of zeros is 1. So this one will become minus 10 by 2, which is minus 5. So x will be, like, here it has, like, just be careful when you're putting the value. You will just put the value minus 5 in hurry. Just be careful. It has given us minus x, so minus x equals to minus 5, so x equals 5. Just be clear about that. This type of silly mistake you will make, I am 100% sure. Okay, 50% of you, like, not 50%, 20% of you guys, I know this type of silly mistake you make in the examination hall, and that's how your marks gets deducted. So just be careful about that. Minus x equals to minus 5. So x will be equals to 5. So you will put x in the NAT answer. So NAT question type may come in this one. So you put x equal to 5. You put 5 in the that scribble, right? Not minus 5. Just be careful about that. So this is the last question. Okay, last question of this lecture, and last question of root locus. So this is a very interesting question. I will prove one thing, and if you can remember, good. If you can't, then no issues. You will solve from basics. So here we have been asked to find where the uh, where will the complex conjugate roots for the following characteristic equation lie. So we have been given this characteristic equation, and we have to find the complex conjugate complex location of the complex conjugate uh, roots. Sorry, like this should be not characteristic equation. This should be OLTF. I'm really sorry about that. Okay, this should be OLTF. So LTV is given. We have to find the complex conjugate roots. So let's like try to plot this. Okay, let's like try to plot the root locus with intuition itself. So first thing what is present is how many number of branches we have. We have two. Like number of poles is greater than number of zeros, and then number of poles will decide my number of branches. How many number of virtual zeros I have? I have one, because I have two poles and only one zero. So one virtual zero and one zero is there anyway. So it will terminate like this. So two branches and one virtual zero. Asymptotes 1. Where will the asymptote lie? Let's solve it directly through mouth itself. Okay, mouth calculation. So obviously I have two poles, minus 1 0. So p minus 1, 2 minus 1 is 1, and it is like this is normal root locus. Nothing is set. Normal root locus. So 1 at t into 2k plus 1 odd multiple divided by p minus 1. So p minus 1 minus 1. So only for one asymptote. So 0, k equals 0. So 1 at t into 1 divided by 1 itself. So minus 1 at t. So it lies on the negative real axis, the asymptote. So like orally you can solve root locus questions. Like simple this one. Obviously difficult ones you won't be able to solve, but simple ones you will be able to solve orally. So like I have two roots, two roots. Minus 2, and I have 1 0, minus 4. So how will the root locus look like here, right? My root locus can't lie here because I have odd even number of poles plus zeros. So it can't lie here. It can lie here. It can lie here, and I have asymptote at the negative real axis also. So obviously, it will be something like this. And obviously this whole area will lie. And what will happen? This is also terminating. This is also terminating. Obviously, I will have two branches here, two different branches. So as they are terminating in different locations, two different branches, and obviously there will be what between two zeros, like this is 1 versus 0 and 0. Between two zeros I will have a break in point. So I will have break in point, and what is happening over here, I have two roots. So obviously I will have a breakaway point, as I mentioned, right? Either I will have breakaway or breaking point for repeated roots or zeros, repeated poles or zeros, or for repeated roots simply repeated poles or zeros. So obviously this, like this represents a break away point in itself because I have two repeated poles. Now I will not be able to draw this perfectly. I will try to draw this like perfectly. Now, one interesting fact about this one is like just a bit of mistake I made, like visually. This won't be like this. I'll just make a few changes here. Yeah, this will be more or less like this. Okay. This will be almost like a circle, which I wanted to tell you, but I am not able to tell you. K equals to infinity. This is k equals 0, starting from k equals 0 itself. And yeah, here I have two roots, right? So this is k equals 0. So here I have some, just hold on a second. So this is my root locus basically. So you might ask like, why is this like this and only, and why isn't this like this? It can be, but this will be like this only, circle only. Okay, I'll prove it to you. Obviously, theta asymptote I got. What is the question is asking us now? Where will the complex conjugate root? So this is not visually here. You are not able to see it visually, but this will be like a circle itself. This will be like a circle itself. So here, right? If you calculate the angle of departure from these poles, so you will see that yes, this is correct. That my root locus will go something like this direction and not in this direction. You calculate, this is the homework for you. Calculate the angle of departure from these two poles. So if you calculate like this one, so you will get it. So here, so just try to understand that this will be the equation of circle. This will be form of circle. So answer will be circle. As what are these? These are complex conjugate poles. So that is what the question is asking. Where will the location of the complex conjugate poles lie? It will lie on the circle. Answer. Now you might ask, sir, I don't believe you. I don't believe you, sir. Can you prove it? Like you can prove the equation for yourself. I will not prove it, but one thing that will prove is that center of the circle will always lie on the leftmost zero. So they may ask the question, right? So they may ask that the circle formed by the root locus, can you find the center of it? So just remember one thing, that the center of the circle will always lie on the leftmost zero. Leftmost zero. What is my leftmost zero here? -4. So center will lie on the -4 itself. If there is circle present. If there is circle present. So how to find like how do you know that yeah, this is the like leftmost zero is the correct answer for the center? So let's take a transfer function. So proof for center of circle. Proof for center circle. So let g of s h of s equals to like a generalized equation s plus a into s plus e plus s plus c. Okay, now what is this? So this is first thing we have assumed, obviously we are assuming on the leftmost zero, so we'll assume that the a is lying on the leftmost side, right? Leftmost side. So a is the leftmost zero, so a is greater than b greater than c. Leftmost zero. So let's find one thing about the breakaway point. So here, right, so what will happen, obviously I will have a break in point and breakaway point. So here, as I repeated, you might seem that the breakaway point is same, but between the break in breakaway point, this is a circle, this is a circle, and the centroid of these two will be obviously the center of the circle itself. So the breakaway and breaking point are the diameters. Okay, I will not prove that this is a circle, that we don't have time, but just trust my words that this is a circle and this is a diameter. So obviously the center between these two will be the what center of the circle itself. So yeah, that we'll do. So let's find the breakaway and breaking point. So I will say that break, x0 is lying on the left hand side, so break in point minus break away point is equals to the diameter of circle. And what does diameter mean? So diameter of the circle, or you can say that what will be the radius. So radius of the circle will be breaking point minus break away point divided by 2. Now what about my center of the circle? Okay, I went from center to radius, sorry. So center will be simply these two, addition of these two divided by 2. Center of these two, right? Center of these two. Center of these two. So simply uh, center of the circle divided by 2. Okay. So this is the case. So let's find the breakaway and breaking points. So how to find that? So for find breakaway and breaking points, breakaway point and how to find those. So basically, like just do that a of s and a dash of s and b of s. What is a of s? A of s is s plus a dash of s equals to 1. And what is b of s? Equals to s plus b into s plus c. So this is this. Now what is b dash of s? B dash of s is simply, like you can do this, what you will get? So one, you will get s square plus b plus c into s plus b into c. So like that one will go away, and so this will be 2s plus b plus c. Okay, sorry if my voice goes away, if I go away sometimes, sorry, this noise, I have to make this sometime work. So this is what a dash and b dash is. So what was the formula for uh, breakaway and breaking points? So for breakaway and breaking points, what you can see is uh, this, we have to equate this one. So a into b dash, so this is s plus a into b dash 2s should be equal to 0. This is what we should equate. So here if you solve this equation, you will get 2s square here, and this is 2s into b plus c, and this is 2as, this is s square plus b plus c into s plus b into c basically. Okay. Okay, we have to subtract this one also, I think. Subtract this, a square minus a dash of s minus b dash of, that's what the equation that we get, right? So this one was the equation, so this will be in subtraction, so this is in subtraction, this is in subtraction. So what will happen is, one s square will get cancelled out, 2as we have, and this is minus a, so this will become equals to 0. So one of these also gets cancelled out, so we have only s into 2a plus b plus c, and we have minus b into c. Okay, this we have. So what this will be, what this will become, so this will become minus b upon, yeah, sorry for the interruption, I think I made a calculation mistake, that's why I had to redo this one. So like, what are the roots? It is minus 2 b upon 2a plus minus b square 4a square minus 4ac, so this is 4a into b plus c plus b into c. So this is what my equation becomes. 4, this is also 4ac. So I can take the 4 outside, and 2 I can divide minus a plus minus, and this 4 is outside, so 4 is outside, hence 2, and 2 divided by 2 is 1, so I won't write anything here. So this will become a square minus a square minus ab minus ac plus bc. So what I can do is, I can take common here, yeah, I can take common as minus a plus minus under root a I can take common here, so this is a minus c, and here if I take common as minus b, this one will become a minus c again. So this one will become something like this, under root a plus minus a minus b into a minus c itself. Okay, so this is how my equation will look like basically. So how to use this right now? So out of this, right, one of them will be break-in point and one of them will be break away point. So I'll have two things, one of them will be valid break-in point and one of them will be valid break away point. Which one will be break-in point? Break-in point, as the zeros are lying on the left hand more side, so obviously something minus adding with this one, so that it will make it more nearer to the origin. So my break sorry, not in breakaway point, breakaway point will be more nearer to the origin, so it is minus a plus under root a minus b a minus c. And what about my break in point? So my break in point will be more further away from the origin, minus a minus under root a minus b into a minus c. So now obviously what was my center and radius, you know, radius is simply this two difference, so hence this by 2 I will just show you the radius and the center. So if you want to remember this formula, well and good. If you don't want to remember, that's fine. Rarely gets asked. Okay, never have been asked, but it may get asked. So that's why I wanted to show you that this type of question also may get asked. So radius simply will be break whatever you want to do. Basically break away point minus breaking point, because we are talking the mod. So you will just take the mod of this one. So what you'll do, you just take the mod of this, right? Mod of this two, because radius is a distance, can't be negative. So it will be simply under root a minus b into under root a minus c. And also, like, do remember what is my zero, what is my poles. So here obviously you have to understand that a is my leftmost zero, and b and c are my poles. B and C are my poles. And what about my center? What about my center? So center will be obviously like this plus this. So this one gets cancelled out, and only we are remaining with minus 2 minus a divided by 2, as this was the form, right? Center equals to breaking point plus breakaway point divided by 2. So it becomes minus a itself. Hence proved. Minus a, which is the leftmost zero. Hence proved. So here what will be my answer? Oh, okay. That won't be my answer. My answer will be obviously the root locus will lie on the center itself. Will lie on the circle for complex conjugate poles. But these things you have to keep in mind. This is the extra that I wanted to explain it to you. Few extra things. So this thing you have to keep in mind. So center will lie on the the center will lie on the leftmost zero. Center will always lie on the leftmost zero. Okay. So this is one thing we have to keep in mind. And obviously the answer for this question is circle. The answer for this question is circle. They will lie on the circle. Complex conjugate roots will lie on the circle. So I have enjoyed the root locus chapter, and next we'll start with the new topic, that is the frequency response, which is a very interesting topic. And yeah, it is also a scoring sub topic, and like there are many misconceptions regarding it. So we'll clear all those things. So I have enjoyed this lecture, and I will see you in the next lecture. Thank you for watching.